Finally, let's go into AutoML tables for tabular data. Tabular data is what you might find in a spreadsheet, for example. While AutoML Vision and NLP are for unstructured data, AutoML Table is for structured data. The development of AutoML Table is a collaboration with the Google Brain team. While the technical details of the project haven't been released yet to the public, the team basically took the architecture search capability used for image classification and translation problems and found a way to apply it to tabular data. Let's describe a dataset where AutoML Tables performs really well. The Mercari Price Suggestion Challenge. Mercari is Japan's biggest community-powered shopping app and marketplace. Mercari created the Price Suggestion Challenge for predicting the price of a product offered on their marketplace so that they could give price suggestions to their sellers. Participants were given some 1.5 million rows of rich data with plenty of noise. The challenge lasted for 3 months and culminated in a $100,000 prize. Over 2,000 data scientists competed for the prize. This plot shows the performance of AutoML tables on the Mercari challenge for several different training times. You can see that after 24 hours of training, AutoML tables pretty much puts you on the leaderboard. Even after only 1 hour of training, you get to the plateau of leaders, which is extremely impressive performance on a million-plus row dataset with significant complexity. Compared to the $100K prize for this challenge, 1 hour of training is just $19. Since the search process for AutoML tables is random, you might get slightly different results if you try to reproduce this performance. The easiest way to import your data into AutoML tables is through BigQuery. You can also import data using CSV files stored locally or on cloud storage. One of the advantages of importing data through BigQuery is its support for arrays and structs. Regardless, for both import sources, your data must have between 1,000 and 100 million rows, between 2 and 1,000 columns, and be 100 gig or less in size. Once your data is imported, the next step is to select the features you want to use and to specify the column you're trying to predict. In the next step of building an AutoML table model, you go through a data validation phase. The purpose of this step is to ensure you're not passing bad data to your model. This includes checking for columns that have too many null values, outliers that are skewing the distribution of a column, and columns that are not correlated to the target you're trying to predict. As you saw in the slide on AutoML tables performance on the Mercari challenge, you can train a model for a variable amount of time. You can set a training budget in node hours to cap costs. By default, AutoML tables will stop training if the model isn't seeing significant performance gains anymore. Once your model is trained, you should look at the training metrics. Be wary of models that are too good to be true. In this case, you'll likely have a data issue you'll need to resolve. For classification, the report includes metrics such as area under the curve for precision recall curve, accuracy, and the F1 score. Also, a confusion matrix is output along with feature importances. These two sets of metrics are particularly useful in diagnosing low-performing models. For regression models, the root mean squared error, mean absolute percentage error, and feature importances are returned among other metrics. Check the AutoML table documentation for a full list of metrics that get generated after model training. It's arguably more important to look at the performance metrics generated on the test set to get a feel for how well your model will generalize. The same metrics generated for the training data are also available for test data. For classification models, it may be useful to set the score threshold to a value other than the default of 0.5. Increase the score threshold to make your classifier output a positive label with more confidence. Once you're happy with your model performance, you can go ahead and deploy it. You have the option of making batch or online predictions. For online predictions, you can make calls using a curl command or one of the Java, Node.js, or Python APIs. The same APIs are available for batch predictions. You can make batch predictions on either BigQuery tables or CSV files. However, the BigQuery data source tables must be no larger than 100 GB. For CSV files, each data source file can be no larger than 10 GB, and if you include multiple files, the sum of all files cannot exceed 100 GB. We return to the question of when should you use BQML or AutoML versus building a custom model. The short answer is, it depends on how much time you have to build the model and what resources you have available. This table may provide some guidance. Given the low barrier of building a model in either BQML or AutoML, give either a try first. If the resulting model is not sufficient, only then should you throw more resources at it. To summarize, Cloud AutoML can build really powerful machine learning models with no coding. The models will be customized to your data. Use AutoML Vision for image data, AutoML NLP for text data, and AutoML Tables for structured or tabular data.